Hi everyone, I'm Sam, and today we're going to talk about blood. Blood. It's one of those things we take for granted, right? Every day our bodies pump it through veins and arteries, coursing like a river, keeping us alive, energized, and functioning. But have you ever stopped to wonder what's really going on in that crimson fluid that's constantly flowing through you? Let's take a dive into the fascinating world of blood. At its core, blood is a life-sustaining substance. Without it, we wouldn't be able to carry out the basic functions that keep us alive. But blood is far more than just a simple liquid inside us. It's a complex, multifaceted system, performing a multitude of vital jobs. To really appreciate what blood does, we need to understand some of the essential components that make it up and how they work together. Blood is made up of four main components: plasma, red blood cells, white blood cells, and platelets. Let's break these down a bit more. Plasma is the largest component of blood, making up about 55% of its volume. It's a yellowish liquid that's primarily water, but it also contains a variety of proteins, electrolytes, hormones, and waste products. The proteins in plasma, like albumin and globulins, help with clotting, immune response, and transporting substances like hormones and nutrients. Think of plasma as the carrier. It's the vehicle that transports everything else. Next up are red blood cells, also known as erythrocytes. These are the most numerous cells in your blood, with over 20 trillion of them circulating at any given time. Their main job is to carry oxygen from your lungs to the rest of your body and return carbon dioxide from your body to your lungs so you can breathe it out. The key to their success is a protein called hemoglobin, which binds to oxygen and carbon dioxide. Hemoglobin essentially turns red blood cells into tiny, efficient oxygen delivery machines. This is why your blood appears red. The hemoglobin is responsible for that vibrant color. Then we have white blood cells, or leukocytes. These are the body's defenders, patrolling for any potential invaders like bacteria, viruses, or other harmful substances. Unlike red blood cells, white blood cells are fewer in number but are critical for protecting the body against disease. They come in different types, each with a specialized role in defending your health. For example, neutrophils are the first responders, jumping into action when they detect an infection, while lymphocytes produce antibodies that specifically target foreign invaders. Lastly, there are platelets, also known as thrombocytes. These are the body's repair crew. Their main job is to help stop bleeding by clumping together and forming clots at the site of an injury. When you get a cut, platelets rush to the scene, creating a plug to seal up the wound. Without platelets, even a small injury could lead to excessive bleeding, so their role in the body is essential for healing. Now that we know what blood is made of, it's time to look at what it actually does. Blood has several key functions that are essential for keeping our bodies in balance. One of the primary roles of blood is transportation. It moves oxygen from the lungs to tissues throughout the body, while also carrying away waste products like carbon dioxide to be exhaled. Blood also delivers nutrients, such as glucose, vitamins, and minerals, to cells so they can produce energy. It's like a delivery truck, picking up cargo from one location and dropping it off at another. This system is incredibly efficient, making sure that every cell in the body gets exactly what it needs to function. But blood doesn't stop there. It also plays a huge role in regulating temperature. When you're too hot, blood vessels near your skin dilate, allowing heat to escape from your body. Conversely, when you're cold, blood vessels constrict to keep heat inside. In this way, blood helps to maintain homeostasis, the body's balance, by making sure everything stays at just the right temperature. Then there's the immune system. As we've mentioned, white blood cells are the soldiers that keep your body safe from harmful invaders. When bacteria or viruses enter your body, white blood cells are quick to respond, launching an immune attack to neutralize the threat. This process is a bit like a battle. White blood cells move in and engulf the invaders, preventing them from spreading and causing harm. It's pretty impressive how much blood is involved in defending the body without us even realizing it. Lastly, blood is involved in clotting and wound healing. Imagine getting a paper cut. It's a tiny injury, but if you didn't have blood to form a clot and stop the bleeding, even something as small as that could become a serious problem. Platelets rush to the site of the wound and form a clot, which eventually hardens into a scab, helping to protect the injury as it heals. This process keeps us from losing too much blood when we get hurt. But there's one more vital role that blood plays in our bodies: hormone transportation. Hormones are chemical messengers that regulate processes like growth, metabolism, and mood. Blood carries hormones from the glands that produce them to their target organs and tissues. For instance, insulin, which regulates blood sugar levels, is carried by blood to various tissues in the body. Without blood, hormones would have no way of reaching their destinations, and the body's delicate balance would fall apart. The story of how we came to understand blood is a long one, filled with curiosity, discovery, and the sometimes frustrating process of unraveling the mysteries of the human body. To truly appreciate how far we've come, we need to take a step back in time and look at some key milestones and figures who shaped our understanding of blood. It wasn't always the sophisticated science we know today. In fact, many early theories were as wild as they were wrong. But through persistence, experimentation, and a lot of trial and error, our understanding of blood has evolved into what it is now. Let's begin in the ancient world, where blood was thought of not just as a biological substance, but as something mystical and symbolic. In many ancient cultures, blood was linked to life itself. The Egyptians, for example, believed that blood was a vital fluid that carried the essence of life. They even had a concept known as the blood of the gods, where blood was thought to have magical properties. Bloodletting, a practice where blood was intentionally drawn from the body to cure illnesses, dates back to these ancient civilizations. But despite the cultural reverence for blood, the scientific understanding of its role in the body was still far from accurate. It wasn't until the ancient Greeks that blood began to be thought of in a more scientific way, though even their ideas were somewhat misguided by modern standards. One of the most famous Greek philosophers, Hippocrates, who is often considered the father of medicine, proposed that blood was one of the 4 essential humors, along with phlegm, yellow bile, and black bile, that controlled the body's health. He believed that an imbalance in these humors led to illness. While Hippocrates' theory about blood as a humor was wrong, it set the stage for future investigations into the role of blood in human health. As the centuries passed, blood was increasingly seen as a vital fluid that could be studied, though much of the early research was based on observation rather than experimentation. The next major step in our understanding came during the Renaissance, a time of incredible intellectual and artistic growth. During this period, scientists began to challenge old theories and seek out new answers. One of the pioneers of this new way of thinking was the Italian physician Andreas Vesalius. In the 16th century, Vesalius made groundbreaking contributions to the study of human anatomy. Through dissections and careful study, he corrected many of the ancient ideas about human physiology, including the role of blood. He showed that the heart was not just a passive organ, as previously thought, but an active pump, circulating blood throughout the body. Although Vesalius didn't completely understand the circulatory system, his work laid the foundation for the next big breakthrough. The real revolution in understanding blood came with the work of the English physician William Harvey. In 1628, Harvey published his famous treatise De Motu Cordis on the motion of the heart and blood, in which he demonstrated for the first time that blood circulates throughout the body in a continuous loop. Prior to this, most people believed that blood was created and consumed by the body in localized areas. But Harvey's work showed that the heart acts as a pump, pushing blood through arteries and veins, circulating it in a closed system. His discovery was revolutionary and marked the beginning of modern cardiovascular science. Despite Harvey's groundbreaking work, there was still much to learn about blood itself. Scientists knew that blood flowed through the body, but they didn't fully understand what blood was made of or how it worked on a microscopic level. The next step in unraveling these mysteries came with the invention of the microscope. In the 17th century, the Dutch scientist Antonie van Leeuwenhoek, using one of the first microscopes, made the remarkable discovery of red blood cells. He was the first person to observe these tiny disc-shaped cells that make up the majority of our blood, and he documented them in great detail. While he didn't fully understand their function, his discovery provided a crucial piece of the puzzle. The microscope allowed scientists to peer into the microscopic world of blood, and this new tool would prove invaluable in furthering our knowledge. Fast forward to the 19th century, and the study of blood began to shift from a focus on its basic circulation to a more detailed understanding of its components. One of the most significant discoveries during this time was the identification of blood groups. In 1901, the Austrian immunologist Karl Landsteiner discovered that there are different types of blood, A, B, AB, and O. This discovery led to a better understanding of blood transfusions and made them much safer. Prior to this, blood transfusions were a dangerous and often deadly practice because doctors didn't understand the importance of matching blood types. Landsteiner's work revolutionized medicine, saving countless lives. The 20th century brought even more advancements, particularly in the understanding of blood at the molecular level. Scientists began to learn more about the proteins and other molecules in blood, such as hemoglobin. In 1959, the American biochemist Max Perutz and his colleague John Kendrew were awarded the Nobel Prize for their work in determining the molecular structure of hemoglobin. Understanding the shape and function of this key protein helped scientists understand how blood transports oxygen throughout the body. By the 20th century, blood was no longer seen as just a fluid coursing through the body. It had become an intricate system of components: red blood cells, white blood cells, platelets, and plasma, each with its own specialized job. Blood had a role to play in everything from immune defense to hormone regulation to wound healing. But the discoveries didn't stop there. The study of blood continued to evolve with breakthroughs in understanding blood diseases, blood clotting, and even blood as a source of stem cells for medical therapies. Today, we know that blood is not only a life-sustaining fluid, but also a powerful tool for diagnosing and treating diseases. Blood tests are a common part of medical practice, allowing doctors to detect everything from anemia to infections to cancer. Advances in blood transfusion technology and blood banking have saved millions of lives. And with the rise of stem cell research, blood continues to be at the forefront of innovative treatments for a wide range of diseases. Even with all the knowledge we've gathered about blood over the centuries, there are still plenty of misconceptions floating around about this essential fluid. Some are harmless misunderstandings, while others can actually be dangerous. So let's take a moment to address a few of the most common myths about blood and set the record straight. One of the most widespread misconceptions about blood is the idea that it's blue in your veins and only turns red when it hits the air. This myth has been passed down for generations, often due to the way veins appear under the skin, looking blue or purple. But the truth is, blood inside your veins is always red. It's just a darker shade of red when it's deoxygenated, meaning it has already delivered oxygen to the body's tissues and is on its way back to the lungs to be reoxygenated. The bluish appearance of veins is simply an optical illusion caused by how light interacts with the skin. When light hits the skin, shorter wavelengths, like blue, are scattered more than longer wavelengths, like red, making veins appear blue to the naked eye. So rest assured, your blood is always red, whether it's in an artery or a vein. Another misconception that many people believe is that blood is just a simple, homogeneous substance. The reality is, blood is incredibly complex, made up of many different components that all play vital roles. It's not just a liquid, it's a dynamic system composed of red blood cells, white blood cells, platelets, and plasma, each with its own job to do. Red blood cells are the oxygen carriers, white blood cells are the immune defenders, platelets help with clotting, and plasma transports nutrients and waste. This intricate system ensures that everything runs smoothly in your body. So next time you think of blood, remember that it's not just a liquid, it's a finely tuned mechanism that's essential for life. On the topic of blood, let's talk about blood donation. Many people think that donating blood will leave them weak or unable to recover quickly. In reality, The human body is remarkably efficient at replenishing the blood it loses. After donating a pint of blood, it typically takes your body a few weeks to replace the red blood cells. However, the plasma and platelets are replaced much faster, often within just a few hours to a day. Far from leaving you debilitated, blood donation is a safe and generous act that saves lives. Donating blood regularly can actually be good for you in the long term, as it helps keep your body's circulatory system healthy by stimulating the production of new blood cells. Some people also worry about blood transfusions and think that receiving someone else's blood could lead to a serious reaction or infection. While it's true that blood transfusions can carry risks, modern medicine has made them incredibly safe. Thanks to the discovery of blood types and rigorous screening practices, doctors can match donor blood to recipients with great precision. Blood banks also test for infectious diseases, so the chances of receiving contaminated blood are extremely low. In fact, blood transfusions have saved countless lives in emergency situations, from trauma to surgery, and advancements in this field continue to improve outcomes. Another blood myth involves the relationship between blood types and personality traits. You've probably seen those quizzes online that claim to predict your personality based on your blood type, especially the idea that people with type A blood are meticulous, type B are creative, type AB are intellectual, and type O are outgoing. While these traits may be fun to think about, there's absolutely no scientific basis for this. Blood type is determined by genetics and refers to the presence or absence of certain antigens on the surface of red blood cells. It has nothing to do with your personality. So, while you might have fun reading those personality charts, it's important to remember that your blood type is not a window into your character. One more myth that needs to be addressed is the idea that blood is a universal donor or universal recipient. This concept, while based on blood type compatibility, is often oversimplified. The idea of the universal donor stems from the fact that people with type O negative blood are often called universal donors because their blood can be given to people with any other blood type without triggering an immune reaction. However, it's important to remember that even O-negative blood must be properly matched with the recipient's blood in certain cases, especially when it comes to platelets or plasma. Similarly, AB-positive individuals are considered universal recipients, meaning they can receive blood from any type, but it's still best practice to match blood types as closely as possible to minimize any risk. While these classifications help guide blood transfusions, the process of matching blood goes far beyond just knowing whether someone has type AB, AB, or O blood. So there you have it, a quick tour of some of the most common blood myths and misconceptions. While some of these misunderstandings have a long history, modern science has helped us separate fact from fiction. Blood is a fascinating substance with a complex and vital role in the body, and understanding it fully can help us take better care of our health. The more we learn about blood, the clearer it becomes just how incredible this life-sustaining fluid truly is. So, let's keep asking questions, challenging the myths, and embracing the incredible science that keeps our bodies alive and thriving. That's it for today, and I'll see you in the next episode.